position, velocity, and acceleration. And this is an extremely important topic, probably one of the top 5 for the course. So let's just jump right on in. Mr. Brewster is playing catch with himself. So basically he's throwing this tennis ball straight up into the air. And the height of the ball is modeled by S of t equals negative 4.9 t squared plus 18t plus 2. So here is S of t, and this is time on the x-axis. And the height of the ball is in meters, and the time is in seconds. Okay, and this makes sense. If you can take a look, it says that he threw the tennis ball. So the tennis ball started at this height, about 2.5. And here's the height of the ball. And then at some point, it slows down and is still for just a moment. And then the height starts to go down until it hits the ground, until the height is 0. So that really makes sense about the position in terms of its height. Okay? So I do want to mention one thing. When something is thrown, we do have a velocity. You could have some positive velocity. But when something is dropped, the initial velocity is 0. And why don't I change this to initial velocity at 0. Those are just some really good things to keep in mind when you're working with motion. Okay, let's go to velocity. So I don't really want you to worry about this graph as far as where I'm graphing everything. So I'm just going to draw this line and kind of come down like that. Again, don't worry about where it's located. And if you notice, this is a straight line, okay? So let's kind of follow along here and see what we have. So our ball is thrown. The height is positive, but it is slowing down. As it goes higher and higher, the velocity gets closer and closer to 0, and then it's 0. And it looks like it's 0 at about 8 seconds, okay? So right here at 1.8 seconds, the velocity is 0. So let's put velocity, and velocity is meters per second. And then this is again time in seconds. So you can see what happens now with this velocity. It then, when we have this ball, the velocity starts to speed up again, but it's in a negative direction as far as y values go. It's going down. So here our velocity is -5, increases to -10, and then it's largely negative. So that makes sense. And finally, let's take a look at acceleration. So if we have acceleration, don't worry yet about where I'm placing these. It's around there, around -9.8. If you know anything about physics, that's the acceleration, the second derivative, and we'll be talking about that. So this is acceleration, and the units are meters per second squared, and this time is in seconds. And it is constant. It is always the same. So over this whole time that this ball is in the air, we always have the same acceleration. And you guessed it, it's acceleration due to gravity. Okay? So now let's talk about why the graphs look like this. Take a look. Here we have a quadratic. Take the derivative of a quadratic, and you get a linear, t to the first power. Take the derivative of that, and you get acceleration, which is constant. So it should all make sense now to state that the position function, s of t, and I'm not sure why they didn't call it p of t, but anytime you see s of t, it is a position function. Velocity is just going to be the derivative of the position function, and acceleration is the derivative of velocity, and it's also the second derivative of position. So Those kind of things are really helpful. What some students write on their tests is SVA. So the derivative of position is velocity, derivative of velocity is acceleration. If you're given position, you have to take the derivative twice to get to acceleration. So some students find it really handy to have SVA on their paper. Then when we get to integration, we'll be going backwards, okay? Okay, let's talk about velocity being the rate of change of position. So if we have a negative velocity, if the velocity is negative, it means that the particle is moving to the left. Now, we usually have this motion on the x-axis, but if you're working on the y-axis, you could also say it's when the particle is moving downward. Okay, when you have a positive velocity, that is when the particle is moving to the right. And you could also say that's when the particle is moving upward. Now, if the velocity is 0, just like we said right here, look at that. The velocity is 0 right here at that time. That is when the particle is at rest. It is not moving backwards. It is not moving left. It is not moving right. It is just at rest. We want to clarify average velocity. We want to be very careful we don't get these mixed up. The key word here is average. And the average velocity on an interval, let's say on AB, average velocity on AB, on that time interval, is S of B minus S of A all over B minus A. Okay? So we want to make sure we don't get those average velocity. We don't want to get that mixed up with the velocity. A very easy concept is speed. And speed is the absolute value of velocity, okay? And note, speed is always positive. So you could think about driving your car 60 miles an hour. Your speed is the absolute value of 60, which is 60. If you're in reverse, maybe in reverse going 3 miles an hour, your velocity is -3 because you're going to the left or backwards, but your speed is still 3. You can see that on your speedometer. Okay, let's move on to a big concept called speeding up or slowing down. And it is as simple as this. If velocity and acceleration have the same sign, then the particle is speeding up. You could think about a person walking forward and then being pushed forward. They sped up. Here the velocity was positive and being pushed, that acceleration. Likewise, if a person, so here they will speed up. Likewise, if you have a person walking forward and then they're pushed backwards, they will slow down. And here, the acceleration was negative and the velocity was positive. So they had different signs. One was positive and one was negative. So here, the particle is slowing down. Now, I want to make sure you understand that the velocity can be positive and the acceleration negative, or the velocity, the velocity can be positive and the acceleration positive, or the velocity can be negative and the acceleration can be negative. Either of those can happen when the particle's speeding up. If the velocity and acceleration have different signs, like the velocity is positive and the acceleration is negative, or velocity is negative and acceleration is positive, we will be slowing down. Let's just work a quick example and take a look at this table. Looking, and maybe pause the video and then turn it back on and try to fill in the conclusion, speeding up or slowing down for each one of these. Okay, you should have already completed this. When the velocity is positive and the acceleration is negative, we will be slowing down. They have opposite signs. The same, even though the velocity is negative this time, the acceleration is positive. The signs are not the same, they are different. We will be slowing down. Now, look at both of these. At time 2, we are speeding up, and at time 4, we are speeding up. Why is that? Because they have the same signs. Okay? Both positive or both negative. We now will talk about an important concept called displacement. And displacement is the net, and net is important, change in position. So a nice example would be starting here and running along a track, coming all the way around, coming all the way back. The displacement here is 0 because the distance or the change in position is 0. Now the distance traveled is that distance all the way around, but displacement is 0. Here's another example. You get in your car, let's say, and start to drive to work, realize you forgot your lunch, then you see it on the back seat, you turn around again, and then you go to work. Well, all of this is the distance traveled, but the displacement is this distance. Okay? So, where you end up minus where you started. Okay? Let's try an example and see if we can practice some of these concepts. So, particle motion from an equation, and then we will work with a graph. So, we are given that the position function is this cubic. And again, they could have said s of t, but they called it x of t. And x is measured in centimeters and time in minutes. And I would suggest always highlighting those. That way you're ready to go and you can find those units because units count. So to find the displacement of a particle during the first 2 minutes, we want to find x of 2 minus x of 0 because we're going to be on the time interval 0 to 2. So x of 2 is 2 cubed minus 4 times 2 squared plus 3. And then we're going to subtract x of 0, which is 0 cubed minus 4 times 0 squared plus 3. And that's pretty simple. We will get a negative 5 minus a 3, and we get a negative 8 centimeters. Okay? Find the average velocity of the particle during the first 2 minutes. That's going to be on the time interval 0 to 2. And the average velocity is equal to x of 2 minus x of 0 over 2 minus 0. And look at that numerator. Do you see that this numerator is the same thing as displacement? So the numerator of average velocity happens to be the displacement over that interval. So we can just write negative 8 over 2. And we end up with negative 4 centimeters per minute. Okay, find the velocity of the particle when t is 4. We first have to find v of t. And v of t is going to be the derivative of our position function. And that's equal to, taking a look at it, 3t squared minus 8t. So now we just have to find, let me just write this out. So v of t is 3t squared minus 8t. And that's what you'll end up writing. I just wanted to make sure you saw this relationship. And so v of 4 is 3 times 4 squared minus 8 times 4. and you will get 16 centimeters per minute. Oops. Okay. Okay, now we want to find the acceleration. So we need to find a of t first, and then we'll plug in 4. So we really want to find a of 4. So acceleration is the derivative of velocity, and that's just 6t minus 8. So a of t is 6t minus 8. So a of 4 is 6 times 4 minus 8. And there's no relationship. It just happens again to be 16. And this time it's per minute squared. I got it a little crowded here, so I'm highlighting these. So now the question is the particle speeding up or slowing down at t equal to 4? So at t equal to 4, acceleration, and actually, why don't I just write it like this? Since a of 4 is positive and v of 4 is positive, the particle is speeding up. They have the same sign. They are both positive. Okay? Finally, let's look at particle motion from a graph. Okay? So this figure shows the velocity. Don't get confused with this x of t. Okay? This is velocity, and this is time. Whoops, time's already written there. So what I don't want you to do is, and I don't see any units for velocity, so we just won't use units on this one. I see time as seconds. So they ask us, when is the particle moving to the right? Okay, this is when the velocity is positive. That's when the particle is moving to the right. And so that is when v of t is above the x-axis. And let's take a look at that, where that happens. It happens on time 0 to 1, and it happens on time, let's say 4.8 to 7. So 0 to 1 and 4.8 to 7. Okay, now let's go ahead and see, when is the particle moving to the left? Well, that's when the velocity is below the x-axis. So that is when the velocity is negative, which is when the velocity is below the x-axis. And when is that? From time 1 to 4.8. Okay. When is the particle's acceleration positive, negative, and 0? So the acceleration is positive, the acceleration is negative, and the acceleration is equal to 0. Let's talk about each one of those. So the particle has positive acceleration when the slope is positive. This is when the slope of the velocity is negative, and this is when the slope is 0. So I have positive slope only here. So from time 2 to 6 is the only time I have positive slope. Now, the only time I have negative slope would be from time 0 to 2 and time 6 to 7. So 0 to 2 and 6 to 7. Okay, when does the particle have the greatest speed? The particle has the greatest speed, either positive or negative, highest values of velocity. So you have 2 and negative 2 since speed is positive. So at t equal to 0 and t equal to 2. Now let's talk about when the particle speeds up. This is when acceleration and velocity have the same sign. And this is when the acceleration and velocity have the different signs or opposite sign. So let's take a look. I just would like to work from left to right. From 0 to 1, we have negative acceleration and positive velocity. So we are slowing down. From 1 to 2, we have negative acceleration and negative velocity, since velocity is below the x-axis. We have from time 2 to 4.8, we have negative velocity but positive acceleration, so we are slowing down. And from time 4.8 to 6, both are positive, acceleration and velocity. And then from 6 to 7, the acceleration is negative because the slope is negative, but that velocity is positive. So we are slowing down from 6 to 7. And that concludes this topic.